And it's very cool to talk about why the swirling action is so critical to making galaxies, to making DNA, to making like the macro and the micro is the same, is that what they discovered with when they go into a river, and you know how rivers they're kind of curvy and they kind of cut into the land, kind of like a vein. It looks like an organic vein. Like if you've ever flown in a plane and looked down on the earth, you see the cutting.
Yeah.
And it looks like an artery.
Yeah.
And what they found is that they take the voltmeters and determine on like if the river bend is bending this way, they take their voltmeters, they can sense that there's more voltage in the water as it's bending around. But on a straight path of the river, the voltage is really low.
Why is that? Why would there be more sort of potential divergent energy in a curve?
Well, I think it has to do with an accelerational turn, like a centrifugal or centripetal turning action creates a mini vortex itself, which causes a voltage gradient. And so with the arc reactor rings, and we'll talk about these, is that when the electricity is being pulsed, it shoots up out. The coils then turn the electrons, called the Lorentz force, and it turns the electrons, and then the electrons start swirling around the electrodes like you're going around a bend of a river. And thus it creates even more voltage. Even though you have a small voltage in, it's like a trumpet. So when you are in music class and you have a trumpet and you put your lips on the trumpet and you go...
Yeah, I never liked that about I know that was what I didn't know. I never got into horn stuff. Yeah.
It's very gross. You have to clean it out all the time. Onto your enemy.
Yeah, the clarinet players always had nasty reed and stuff. But anyways, I shouldn't say
but yeah, the oboe had anyway, we could diverge, but the trumpet, you'd put in a very small input signal.
Yeah.
And then the output signal is just enormous.
Yeah.
And so Mother Nature has used these mechanisms to cause planets to form, to cause galaxies to form, to cause nebula to form. If you're not using these amplification techniques, you're not going to get, planetary formation. You're not going to get cold nuclear fusion. If you keep smashing things together really hard, really with massive amounts of voltage and amperage, you're just going to get death. As Victor Schauberger would say, it's just death. Do implosion and you get life.
It makes so much more sense. It's funny about that shape, the shape of that horn, or the shape of the vertice, or not vertice, but
it's a vortex.
Yeah. So that cross section of that's the same shape as if you took the octaves in music. You take one octave and then double it and double it and double it and double it. You get this parabolic.
Is that an exponential curve?
Yeah. And that's basically like what's happening in that vortex. Is it's coming in nice and shallow, and then it starts ramping up to this very steep, almost straight linear.
So in music, when you're going up the keyboard, like from 1 to 12, right?
Yeah. Nice.
The sound, the sounds from, let's say if you're in 1 to 12, is a doubling from 1 to 2?
1 to 1.
1 to 1 is a doubling.
When it goes all the way from 1 to the next 1, or 2 to the next 2, or 3 to the next 3.
Got it.
The frequency has doubled.
And if you were to put that on a graph, that would be kind of an exponential curve anyway, right?
Yeah, and that same curve shape, not coincidentally.
Yeah, it's funny. It's funny how nature mimics music a lot.
All over the place. More and more, I notice it. After these conversations and studying music theory so much, it's all about frequencies,
waves, frequencies, and vibrations. Got it. I got it down, buddy. I've been practicing.
Yeah, it's all about that. I mean, over and over again, though. Even when you look at the shape of a DNA from above, the cymatic patterns are the same things. Now, why is that? Like, that can't be a coincidence. It